Hello and welcome back. In this lecture, we learn how to calculate hydrostatic force on a vertical surface. In video 17, we have seen that hydrostatic pressure at a location can be related to fluid density ρ, height from a reference location, h, and pressure at that reference location. From this equation, it is evident that pressure varies with distance h. Consider water in a tank as shown in figure, with free surface open to atmosphere. In this video, we will discuss how hydrostatic force acting on vertical surface BCEF can be calculated. Since this tank is placed in atmospheric pressure, force exerted by the atmospheric pressure on both sides of the vertical plane BCEF cancel each other. Therefore, the hydrostatic force is only due to the water, acting on the area BCE-F'. Consider an elemental area, dA, at a distance, y, from the free surface of water, on this surface. We can calculate hydrostatic force on this elemental area. By integrating this elemental force for the total area, we get the hydrostatic force acting on the vertical surface BCEF. Since the integral y dA is the first moment of area dA about axis F'-E', this can be written as yc times area, where y, c, is the distance of centroid from this axis. In order to find the location of resultant hydrostatic force, we can equate moment of the resultant force to the summation of moments of elemental forces. From equation 1 and 2 we can find the location of resultant force from the free surface. Using parallel axis theorem, equation 3 can be modified as equation 5. In equation 5, Ixc is the moment of inertia of area BCE-F', about the axis Ixc. Consider the previous example. Calculate the hydrostatic force acting on the vertical surface and its location. To find the resultant hydrostatic force, we can use the previous equation derived. In order to find the location, first we need to calculate the moment of inertia of the area. Then, use the equation derived earlier. The resultant force is acting 1.33 meters below the surface on the vertical wall. Imagine that the tank is completely filled with water. Calculate the hydrostatic force acting on the vertical surface and its location. To find the resultant hydrostatic force, we can use the previous equation derived. In order to find the location, first we need to calculate the moment of inertia of the area. Then use the equation derived earlier. The resultant force is acting 3.33 meters below the surface on the vertical wall. A closed cylindrical container completely filled with oil is lying as shown in the figure. The radius is 1 meter. Calculate the hydrostatic force on one end of the container. We will solve this problem in class. Thank you for listening.